Okay, here I am working one of these construct the function based on information about the derivative type problems. Look at how much information there is. There's a lot there. We're just going to break it down and go slowly, step by step. All right. I suggested in class that we start by looking at the second derivative because that tells you whether it's concave up or concave down and where inflection points are. I think that's not a bad idea, so let's start with that. I'll do my rough draft in pink and then make the final copy in dark ink. So looking at this, it is the second derivative is greater than 0. That's concave up. It's a U-shape up between 1 and 4. So just somewhere in here between 1 and 4, I know it's basically an upward shape. Could be a left half or right half or some part in between, but it's that upward shape. And then also when it's greater than 6. So it's out here, it's basically like a U shape out here as well, greater than 6. And then it's concave down. That's the second derivative is less than 0. It's basically concave down if it's less than 1, so downward out here, and then also between 4 and 6, so downward like that. Okay, so that starts to give you a picture to start with. Then I'm going to jump up to the beginning and say, all right, our derivative is 0 right here at these specific spots. So that means a tangent line is horizontal here at 0. That kind of makes sense right there at 0. And then at 3, so there's a local minimum at 3 right there. That sort of seems to fit. And then also at 5, which also seems to fit. So that kind of confirms that. And then the slope of our function, the derivative, and notice the difference between a specific point and just an x. This is talking about the derivative of the function being positive. That's greater than 0 if x is less than 0. So again, that kind of makes sense. Here our slope is positive all the way up to 0 or between 3 and 5. That makes sense there, that any slope is positive between 3 and 5. It's a negative, less than 0 slope, a negative slope if x is greater than 5. So that makes sense. We got a downward facing slope there when it's greater than 5. And if it's between 0 and 3, so there's 0 and 3. So again, a negative slope right there makes sense. Okay, so then if we just go back to our second derivative, that point at which it transitions is where we're going to get inflection points, and that's going to be at 4. Transitions right here at 4. There'll be an inflection point right there. I think I'm going to start going to black. So inflection point at 4 where it changes, concave up, concave down, and then also at 1, concave up, concave down, and then at 6 it's going to transition because it says so right there. 6 is another transition point right there. All right. Well, if I then look at my final piece of information, that is that as x gets closer and closer to infinity, so way out here, it approaches 1. All right, well, if that's 1 right there, that's going to be an asymptote for this, and it's going to come down here, and I'm just going to squeeze it in my graph like that. Approaches 1, and then it's going to come up to our maximum point, go down like that. There's our inflection point where it turns concave up, and then it's going to go, oh, look at that, I have f of 0 being 3, so I'm going to have to get that up to that maximum and then kind of come down like that. And this point here, 1, 2, and there's 3. So I'm sort of cheating there at the very end, but that is a graph based on those preconditions. Thanks a lot. Okay, I am taking a look at problem number 18 out of the book on page 174, I think. This is the one that we looked at in class, and it just gets confusing because of the absolute values, but I think we can make sense of it now. Starting again at the second derivative, just to get a sense of concavity, up or down. Here it is, second derivative is less than 0, so that's concave down between -2 and 0. So the shape is going to be sort of upside down U between there and 0. And then it says there's an inflection point at 0, 1. So right here, it's going to transition to then it has to be concave up at least some part in here, because if not there would not be an inflection point. Then it says that the slope of our function is going to be exactly equal to -1 when the absolute value of x is bigger than 2. So that means that negative 2 and 2.1 and 3 and -4, 5, and 6, it's going to be -1 slope. So here and beyond, the slope is going to be over 1, down 1. And then at 2 and 3 and 4 and 5 and beyond 2, it's going to be also -1. So that's got to be facing, that's got to be going, whoops, that's a positive slope, sorry. Look at that, positive slope right there. A negative slope means it's going to be going like that. So that's a little bit strange that it turns from concave down to going up. So it will not be differentiable at that point if that turns out to be true. And then it goes like this down there. That's a negative slope beyond 2. All right, so let's then see up here if we've got a positive slope when x is trapped between 1 and 2, and then that also works for -1 and -2. If you think about it, x could be -1.1, -1.5, and then the absolute value is trapped between 1 and 2. So it's a negative slope, a positive slope up to, between 1 and 2, -1 and 2. That's going to be a positive slope there, which makes sense. And then a positive slope here also makes sense. Again, just reading the absolute value right there. When x is between 1 and 2, it's going to be a positive slope, and then between -1 and -2, it's going to have a positive slope. Then up here it says that the derivative at 1 and at -1 is 0. So we're going to have a horizontal line be tangent at that spot, and at negative and at +1. So okay, so right there. So if we have an inflection point right there, then this is going to have to come down and be lower right there, and then go up. So that's got to be our lowest spot, and be concave upwards, and then transition to concave downwards. And then it says the derivative is less than 0, so we get a negative slope when x is trapped between 1 and -1. So a negative slope down, 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 still negative slope. That makes sense. Okay, so I think that we can sketch this thing, and it'll look like this. Slope of -1, straight line, and then it goes up to its high point, and then comes down to its inflection point, turns around and is going down to its lowest point right there, and then goes up, and I guess can just go like that. I don't think there's any rules out there saying it does anything different. And that is what 18 will look like.